To summarize the result, if f is increasing on the interval a, b, then the left sum ln is an underestimate and the right sum Rn is an overestimate. The exact integral is in between. If f of x is decreasing, then the left sum is an overestimate and the right sum is an underestimate. If the graph of f is concave down on the interval a, b, then the trapezoid lies below the graph, so the trapezoid rule underestimates. If the graph of f is concave up, then the trapezoid rule overestimates. The opposite is true for the midpoint. If f is concave down, the midpoint overestimates, and if f is concave up, the midpoint underestimates. Error bounds theorem. Suppose the absolute value of the second derivative is less than or equal to k for x between a and b. If the error bound using the trapezoid, which is defined to be the absolute values of the difference between the exact integral and the trapezoid estimate, and the error bound using the midpoint, which is defined to be the absolute value of the difference between the exact integral and the midpoint estimates, are the errors of the trapezoidal and the midpoint rules, then the absolute value of the error using the trapezoid rule is less than or equal to k times the quantity b minus a cubed over 12n squared, and the absolute value of the error using the midpoint rule is less than or equal to k times b minus a cubed over 24n squared. The area for the midpoint is usually half of the area of the trapezoid rule.